Okay, I'm talking to the students. Okay, guys. I'm making you a video. I'm in the hospital now with my husband. So there will be some background noise going on. But this is a very interesting topic. It isn't just me saying this, of course. It just is a very interesting topic. All right, let me see if I can expand the screen just a little bit. All right, there we go. And let me see if I can pull this down. Well, anyway, it's about covalent bonding, particles stuck together by forces of attraction. So you didn't learn about forces of attraction. It's just that these are more partial charges, so they aren't the heavy-duty ionic charges. All right, so we finished all of the ionic compounds, and that was a lot of stuff. We'll do the labs associated with it when I get back. All right, now, covalent bonding is the other main kind of bonding between atoms, though, rather than ions. So they're sharing two electrons rather than them being transferred to create ions. So sharing two electrons between atoms. So we'll show where they're sharing it in a few moments. All right, so the kinds of covalent molecules are just nonmetal elements that are diatomic, which we've talked about, small nonmetal molecules like water, small and medium carbon-hydrogen backbones such as glucose. All right, all these right here that you can tell they have a lot of carbon and hydrogens that form the skeleton of the molecule. And then macromolecules such as proteins and DNA that are enormous are also covalently bonded. All right, so we're going to learn how to name these because these are very important molecules even though they're just small. And notice they're made out of nonmetals. So just these elements here, the halogens, oxygen, sulfur, selenium, nitrogen, phosphorus, carbon, and hydrogen. So most of these are simply made of these few elements. So they're easy to identify. All right. So what are the key features of covalent bonding? Well, number one, they are weaker than ionic bonds. Number two, they're between similar kinds of atoms rather than the polar opposites of ionic bonds. Two electrons are shared in this rather than creating an ionic lattice. And examples of covalent bonds that we're going to look at are these molecules, and then we're also going to look at these diatomic elements, how that bonding works. All right. Excuse me. So, covalent bonding. Why are they weaker than ionic bonds? Well, they occur between atoms rather than through oppositely charged, full charged ions, +1, +2, +3. All right, so these are full-bodied ions. But covalent bonds are weaker than ionic for that reason because there are only partial charges. So I hope you're taking notes as I am talking. These are only partial charges. Secondly, between similar atoms, covalent bonds occur between the nonmetals that I showed you up here. See how similar they are? They're all on the same side of the periodic table and very close together. So the chemistry of these atoms is very similar. So what's weird about covalent bonds is they occur between similar kinds of atoms, particularly nonmetal atoms. So they're very different from the ionic bonds between metals that form positive ions and nonmetals that form negative. All right, two electrons are shared. Usually each atom provides an electron in a pair. how about I put an electron in the pair? All right, rather than an ionic lattice. And the 4 examples. So we're going to use Lewis dots to show examples of these kind of molecules. So let's make this really big so I can be tidy. All right, so I'm just going to go and get some colors. All right, so we have hydrogen, which just has one of these electrons. And we have fluorine that clearly needs another, right? So let's see how that works in actuality. All right, so that is hydrogens. And then fluorine, if it scoots over, all right, has one here, and hydrogen has one here. And by sharing these 2 electrons, this is called a shared pair of electrons. All right, so this is a covalent bond, and it's made of 2 electrons. All right, the formula of these is HF because there's one of each. All right, now let's go down here to H2O. All right, now this Lewis dot structure that we draw will show why 2 hydrogens are needed. All right, so I'm going to draw the oxygen in the center. All right, and 1, 2, 3, 4, 5, 6. We know that oxygen has 6 valence electrons because it's in group 6A. So clearly it needs another one here to form a pair and another one here to form a pair. Hydrogen, as we drew up here, let's go look at it again, just has one. So we're going to need more than one of these in order for it to work. So we'll put a hydrogen here, all right, with its electron, and a hydrogen here with its electron, all right? And then that's how we have an oxygen with one covalent bond to this hydrogen and another covalent bond to this hydrogen, all right? So the formula is 1 oxygen and 2 hydrogens, O1H2, or H2O, all right? So we showed that there are 2 covalent bonds, and they're between, each is between oxygen and hydrogen. 2 covalent bonds between oxygen and hydrogen. So water has 2 covalent bonds. Yes, hon?
Really?
Okay, so now we have NH3. This is called ammonia. All right, that's its old name from the time of alchemists. So we know nitrogen has 5. 1, 2, 3, 4, 5, right? And hydrogen we know just has 1, all right? So clearly, nitrogen has 3 problem areas where it doesn't have a pair. So let's put that guy, nitrogen, in the center. All right, so I will put 1 here, 2, 3, 4, 5, and we can see in each one of these places, nitrogen has a need for another atom. Since hydrogen has 1 to provide, that's what it will do. Remember, there are millions of hydrogen atoms and millions of nitrogen atoms. So they don't have to go looking. Oxygen comes and bonds because it fits. All right, so here is the hydrogen bonding, and we can see that the correct formula of this would be 1N and 3 hydrogens. All right, so how many covalent bonds are there? Here's one. They look like they're in a pea pod, kind of, don't they? All right, so 3 covalent bonds, 3 covalent hydrogen-nitrogen bonds are in ammonia. Carbon tetrachloride is a bigger molecule, but we just do the same thing. We put carbon, and then it has 4 valence electrons. All right, and chlorine, we know, as a halogen, has 7. 1, 2, 3, 4, 5, 6, 7. All right. So this guy needs to have 1 there. This guy needs 4 to have all the pairs. So remember how we said electrons like to pair up? So that's what these little dots are showing. These little dotted line circles are showing that carbon wants to have 8 electrons, but that means 4 pairs of electrons. Chlorine has 7 electrons and wants 1 more to have 4 pairs of electrons. So we can see that it's 1 chlorine that will fix one of these holes. So let's put carbon in the middle. All right, once we kind of know the situation. Now we can add a chlorine here. I'm going to make chlorine's electrons to look like little X's so we can tell the difference. All right, so here's 1 covalent bond. And then chlorine also, because there's millions of these chlorine atoms, will nestle up here so it can share electron with carbon. Same thing here. Chlorine is going to attach where it can share that 1 and create a pair of electrons like that. And then finally the same thing here, where chlorine moves in with its X electrons. All right, and we have, all right, I marked them now. So there are 4 covalent bonds, and in fact each one of them happens to be a carbon chlorine bond. 4 covalent carbon chloride bonds. All right, so this is 2 shared electrons. In a pea pod is what it looks like. 2 shared electrons. All right, now I wanted to show you this one. We talked about these diatomic molecules. We know there's H2, N2, O2, and then the 4 halogens, F2, Cl2, bromine 2, and iodine 2. All right, these are the 7 diatomic elements. Hi. He's trying, yeah.
It's good. Okay.
His breathing's much better.
Go ahead. I'm probably drinking coffee.
Thank
Do you
you.
need coffee?
No, I'm fine, thanks. They're very nice in this hospital. All right. Oops. Not atoms, but elements. And they create, when 2 of them are bonded together, they create a molecule. So let's show how this works with iodine. All right. We know iodine has 3, 4, 5, 6, and then it has this vacancy here, right? But another iodine has exactly the same vacancy, doesn't it? So if these 2 overlap, all right, then this becomes like that, and the electron, the 7th electron for iodine goes in there. So this is like saying this, that there's one covalent bond between the 2 iodine atoms. Oh, you probably hear the game going on. My son graduated from Purdue, so the Purdue game is going to be on in just a minute. All right, it's March Madness. So let's look at fluorine now. It will be just like iodine because each fluorine, all right, remember how it has 7 electrons. So another fluorine will come. 1, 2, 3, 4, 5, 6, 7. And by sharing that extra electron they have that isn't bonded, it's unpaired, now they each have a shared pair of electrons between the 2 atoms. All right. Now, one question I want to say, where are these electrons coming from? What's the source of these electrons? The electrons, how about I put the 2 electrons shared are valence electrons. So let me show you what that would look like. All right, so fluorine is in row 2. So here's the nucleus. All right, and then there's 1 ring, and then the second ring. The first ring has 2 electrons. The second has 7. All right, so this one right here, there's no electron right there in the valence shell because there's only 7. So let me show you what happens. First, I'm going to make this smaller. Then I'm going to move it down here. All right, then I'm going to paste another. I didn't get what I thought. Let me try this again. Wait till I show you this. You know what? Well, let me do a paste and see if we did it. Okay, now, this one, I'm going to rotate it. All right, see how I rotated it? So now we can see how these overlap. So look, what happens is these 2 overlap just like that. So see where they have this emptiness? I'll make it huge now. All right, see where there's an empty one here and an empty one here. So what they're doing is sharing the one that belongs to the other. All right, so in this blank then, they have this one being shared with this one. All right, and then this is the covalent bond. In the overlap between 2 energy, within 2 valence shells. the valence energy level of each atom. All right, so they each have 7 in the valence. And so what I did, to take the 2 that they put side by side, and I colored them blue to show where the shared pair is. So this is the shared pair of electrons. So in covalent bonds, the 2 atoms overlap. And what overlaps? Their outermost energy level overlaps, just like I showed you with these 2. Now, wasn't that a remarkable artistic achievement for your 3rd grade art teacher? All right, so let's go down here. Now, after we've done those, all right, so we have the conclusions. Now, the essential questions, I didn't pose them at the beginning, but you can answer them now because the lesson was all about these. That a covalent bond is between 2 particles, and explain who those particles are. Are they ions? Are they atoms? What are they? 2, explain why a covalent bond is weaker than an ionic bond. It is. Explain why. 3, explain what the atoms share in a covalent bond when they overlap. 4, explain why HF has 1 covalent bond, whereas water has 2 covalent bonds. Those were 2 of the examples we did. Explain what kind of bond holds diatomic molecules together. We did a few of those. And finally, I want you to do the electron dot covalent bonding of H2S. All right, so that is your mission right now, and I will talk to you later. Thank you for being at the hospital with me. All right? Adios. Answer these questions now.